Hi everyone, in this video we are going to see how to find the equation of a circle that touches the y-axis and has an x-intercept of 2l unit. Let's suppose we have a circle like this whose center is at point C having coordinates h, k, and let's suppose the circle cuts the x-axis at points A and B and it touches the y-axis at point D. Next, I am going to drop a perpendicular from C onto the x-axis as well as onto the y-axis. Let's suppose the perpendicular landed at point E on the x-axis and at point D on the y-axis. If we are given the coordinates of the center of a circle, then we know we are talking about a very specific circle, just a single circle, right? But if we are not given the coordinates of the center, however, we are given the radius and some other information, then there could be multiple possibilities. So in this case, let's suppose we are talking about a circle whose radius has been provided, a specific radius, and we have not been provided with the coordinates of the center, then is this the only possibility? Well, you can think of it like this. You can think that, hey, the circle could be in the second quadrant also, which might look like this. It still has the same radius and same x-intercept, but center is located in the second quadrant. What could be another possibility? Well, the circle could also be in the third quadrant, the center in the third quadrant. There again, it could have the same radius, same amount of x-intercept, but still be in the third quadrant. And similarly, we could have a fourth possibility also, where the center could be in the fourth quadrant and the circle still has the same radius and the same amount of x-intercept. So if we are told that the radius is something and the x-intercept is something, then actually there are four possibilities. And in such case, we have to find out all four equations of the circle. That means whatever equation that we find out, that should represent all four of these possible circles. Now let's suppose this one circle cuts the x-axis at points A and B and it touches the y-axis at point D. Next, I am going to do a little bit of construction here. I am going to drop a perpendicular from C onto the x-axis and onto the y-axis. Let's suppose the perpendicular landed at point E on the x-axis. So CE will represent the y-coordinate of the center and CD will represent the x-coordinate of the center. And that will be equal to the radius of the circle also. H will be numerically equal to the radius of the circle. And next, I am going to join the center with the point A. And also I have joined the points A and E. Now let's talk about the first scenario where we have been provided with the radius of the circle and the x-intercept. We have not been provided with the location of the center. So in that case, we can say that the x-coordinate of the center will be equal to plus or minus the radius. Also, if you look at the chord AB, it is a chord of the circle and we have drawn the perpendicular CE onto this chord. That means the point E will bisect this chord. That means AE will be equal to EB. And also we know the length of AB, which has been provided as 2L unit. So from there we can say AE will be equal to L unit. Now if you look at the triangle CAE, it is actually a right triangle because CE is perpendicular to AE. So on this right triangle, if we use the Pythagoras theorem, we can say CE squared plus AE squared is equal to CA squared. And from here we can say that CE squared is actually equal to K squared and AE squared is equal to L squared and CA squared is equal to R squared. So we have K squared plus L squared is equal to R squared. And here we are trying to calculate the value of K. So we can say K squared can be written as R squared minus L squared. And from here we can say K will be equal to plus or minus square root of R squared minus L squared. Next, let's try to find out the equation of the possible circles. Let's begin with the fundamental equation, which is x minus h whole squared plus y minus k whole squared is equal to r squared. And here we are going to plug in the values of h and k. And finally, our equation will look like this: x plus or minus r whole squared plus y plus or minus square root of r squared minus l squared whole squared is equal to r squared. Here we know the value of r and the value of l because those are the two pieces of information that have been provided in this scenario. So our equation can be written like this, and that is the combined equation of the four possible circles. If we use the different combinations of plus and minus sign in the two parentheses, then we can come up with four equations for the four possible circles. Next, let's take a look at the second scenario where we have been provided with the x coordinate of the center and the x-intercept of the circle. We have not been provided with the y coordinate of the center, so that is something we have to calculate. And also because we have been provided with the x coordinate of the center, the numeric value of the x coordinate will be equal to the radius of the center because the circle touches y axis. So the x coordinate of the center will be numerically equal to the radius of the circle. And how many possibilities we have here? Well, when we have been provided with the x coordinate of the center, we have only two possibilities. Depending on the value of the x coordinate, the circle can either be above the x axis or below the x axis. Those are the only two possibilities. And here r can be denoted as absolute value of h, because radius will be equal to the numeric value of the x coordinate. And from here we can say r squared will be equal to h squared. And now let's try to find out the value of k. We have just seen that k is equal to plus or minus square root of r squared minus l squared. In this case, in place of r squared, I have written h squared because r squared is also equal to h squared, and we know the value of h and l, so I am trying to represent the value of k in terms of h and l. Next, let's try to find the equations. If we begin with the fundamental equation, it is x minus h whole squared plus y minus k whole squared is equal to r squared. And here let's plug in the values of r and k. So our equation going to look like this, and that is the combined equation of the two possible circles. Using the plus sign and the minus sign in the second parenthesis, we can derive two equations from here. Next, we are going to take a look at a third scenario. In the third scenario, let's suppose we have been provided with the y coordinate of the center and the x-intercept of the circle. So in this case, what are the two possibilities? Well, because we have been provided with the y coordinate of the center, the circle can either be on the right hand side of the y-axis or on the left hand side of the y-axis. So here again we have only two possibilities. Now here we have to somehow find the value of h, which is again numerically equal to the radius of the circle, and we are again going to use that little right triangle and use the Pythagoras theorem. We can say that c squared plus a squared is equal to c squared. And from here we can say that k squared plus l squared will be equal to h squared, because CE is equivalent to k and AE is equivalent to L, and then CA is equivalent to the radius, which is again numerically equivalent to the x coordinate of the circle. So k squared plus L squared is equal to h squared, and from here we can say that h will be equal to plus or minus square root of k squared plus L squared. And also we can say that r will be equal to the absolute value of h, and r squared will be equal to h squared, which is again equal to k squared plus L squared. Now let's try to find out the equations of the two possible circles. Let's begin with the fundamental equation, which is x minus h whole squared plus y minus k whole squared equals r squared. And if we plug in the values of h and r, our equation looks like this: x plus or minus square root of k squared plus L squared whole squared plus y minus k whole squared is equal to k squared plus L squared. Here I have denoted everything in terms of k and L because those are the two pieces of information that have been provided in this scenario. So this is the combined equation of the two possible circles. Using the plus and minus sign in the first parenthesis, we can come up with two different equations, and they will represent the two possible circles. I hope things are clear up to this point. Next, we are going to work on a couple of examples. Here we have the first example that says find the equations of the circles that have radius equals 5 unit and cut an x-intercept equals 8 unit. So we have been provided with the radius and the x-intercept, and this is actually same as the first scenario that we have already discussed in this video. We have been provided with the radius and the x-intercept, so there are actually 4 possibilities. Now let's try to solve it. Here we have been provided with the radius as 5 unit, and from here we can say then h will be equal to plus or minus 5, and also we have been provided with the value of the x-intercept, which is actually 2L, that is equal to 8 unit, and from here we can say then L will be equal to 4 unit. And what will be the value of k? Well, k is equal to plus or minus square root of r squared minus L squared, that we have already seen earlier in this video. And from here if we plug in the values of r and L, so k will be equal to plus or minus square root of 5 squared minus 4 squared, which is equal to plus or minus square root of 25 minus 16, and that is equal to plus or minus square root of 9, which is equal to plus or minus 3. So we have found the value of k, which is equal to plus or minus 3, and we also have the value of h, which is equal to plus or minus 5, and we know the radius, so we should be able to create the equations. we can begin with the fundamental equation x minus h whole squared plus y minus k whole squared is equal to r squared. And here if we plug in the values of h, k and r, our equation looks like x plus or minus 5 whole squared plus y plus or minus 3 whole squared is equal to 5 squared. And if we expand it, we get x squared plus or minus 10x plus 25 plus y squared plus or minus 6y plus 9 equals 25. And the positive 25 on both sides of the equation will cancel out each other, and we are going to be left with x squared plus y squared plus or minus 10x plus or minus 6y plus 9 equals 0, and that is the combined equation of the four possible circles. Now let's try to write down each of the equations separately. The first equation could look like this. If we use the plus sign for the x term and the y term, it will be x squared plus y squared plus 10x plus 6y plus 9 equals 0. And for the second equation, I am using a minus sign for the y term, so our equation looks like x squared plus y squared plus 10x minus 6y plus 9 equals 0. Next, I have used a minus sign for the x term and plus sign for the y term. So here the equation looks like x squared plus y squared minus 10x plus 6y plus 9 equals 0. And finally for the fourth one, I have used minus sign for both x and y terms. So the equation looks like x squared plus y squared minus 10x minus 6y plus 9 equals 0. And those are the four possible equations for the circles here, and that is our answer for this question. I hope everything made sense so far. Next, we are going to take a look at another example. The example says find the equations of the circles that cut an x-intercept of 6 unit and have the center's x coordinate equals negative 5. That means the x coordinate of the center would be negative 5, and we have been provided with the length of the x-intercept which is equal to 6 unit. So here we have been provided with the value of 2L and the value of h, which is the x coordinate of the center, and the unknowns are radius and the y coordinate of the center. We have been provided with h, which is negative 5. We can say radius will be equal to absolute value of h, that will be equal to 5. And also we have been provided with the length of x-intercept which is 6 unit. So 2L is equal to 6 unit, and from here we can say L will be equal to 3 unit. And next, let's try to calculate the value of k, the y coordinate of the center. We can say k will be equal to plus or minus square root of h squared minus L squared. That is something we have seen earlier in this video, and that will be equal to plus or minus square root of negative 5 squared minus 3 squared, and that is equal to plus or minus square root of 25 minus 9, which is equal to plus or minus square root of 16, and that is equal to plus or minus 4. So now we know the value of h, we know the value of k, and we know the value of r, so we should be able to come up with the equations. If we begin with the fundamental equation, and here if we plug in the values of h, k and r, then our equation going to look like this: x minus negative 5 whole squared plus y plus or minus 4 whole squared is equal to 5 squared. And from here we can write it as x plus 5 whole squared plus y plus or minus 4 whole squared is equal to 5 squared. And then if we expand it, it's going to look like this: x squared plus 10x plus 25 plus y squared plus or minus 8y plus 16 equals 25. And the positive 25 on both sides of the equation will cancel out each other. So we are going to be left with x squared plus y squared plus 10x plus or minus 8y plus 16 equals 0. And here we have actually two equations hiding. Using the plus and the minus sign for the y term, we can actually write down the two equations separately. The first equation could look like this: x squared plus y squared plus 10x plus 8y plus 16 equals 0. Here we are using the plus sign for the y term, and using the minus sign for the y term, the second equation will look like x squared plus y squared plus 10x minus 8y plus 16 equals 0. And those are the equations of the two possible solutions for this particular example, and that is our answer. In this video, I am not going to solve an example for the third scenario. However, I am going to leave that to you to give it a try. Try to come up with an example for the third scenario and try to solve it yourself. Just simply follow the steps that we have discussed earlier in this video, and you should be able to come up with the possible solutions. I hope everything made sense. Thank you for watching. See you in the next video.